Hey, hello guys. Good evening. Welcome back to our November week 3. Okay, I can see that not everyone is here yet. So let's wait for a while. Yes, Trisling, hello. Good evening. So we are going to hang on. Right, so welcome. Hello, Xinyu. So is this your first time here? Okay, so what are we doing today? We are going to do revision of our chapter 4. Have you posted the answer for 1 and 2? Oh, I haven't yet. I haven't yet. I will. Because I'm a bit busy these 2 weeks. So see if I can do it by this week. I hope I can. Sorry for that. Right, anyway, let's go to our chapter 4. This is our revision for this mineral chapter, page 35. Okay, page 35. Please get yourself here. Where's everyone? Why is there only 6 of you today? Okay, anyway, so let's begin with our page 35. Okay, so if you still remember this chapter, this is our mineral chapter. There is that list of metals you need to memorize. I hope you still remember. Okay, anyhow, so let's look at number 1. So we have 4 minerals here. We have something called bauxite. Right. There is no need for you to memorize what bauxite is, but just to let you know, bauxite is aluminium oxide. This one I've mentioned in my class few months ago. Bauxite is the mineral name. Okay, bauxite is the mineral name. Aluminium oxide is the scientific name. All right, it's just like, for example, tin oxide. Okay, tin oxide. Tin oxide is the scientific name, but the mineral name we call it cassiterite. Okay, cassiterite. Do you know what is cassiterite? Do you know what is cassiterite? This one, in BM, we call it cassiterite, or in a more easy to understand term, we call it biji timah. Right? I'm sure all of you hate this word. Right? Oh my God, biji timah, sir. Okay, I'm sure you have seen this in sejarah plenty of freaking times. Right? This word brings back, bad memories, like some sort of Vietnam War flashback. Okay, so I mean, if you tell normal people, you don't say tin oxide, they don't understand. You have to say tin ore. Okay, you have to say tin ore. That means biji timah lah. Okay, that's the mineral name. Okay, that's what people understand. Right, so same case here. So bauxite is actually aluminium oxide. So what is the element that's present here? What are the elements in aluminium oxide? You have your aluminium, of course, and you have oxygen, right? So when aluminium and oxygen, they get married, they form aluminium oxide. So that is your aluminium oxide. And of course, what is hematite? This thing is called your iron oxide. And as you would have guessed it, this contains iron and oxygen. So it's called iron oxide. Iron and oxygen. Okay, and then of course galena. Galena is what we call lead sulfide. Okay, lead sulfide. So as the name says, this contains lead and this contains sulfur. Okay, you don't need to memorize this lah, guys. Don't need to memorize this. In exam, usually they will give you this. And of course, what is malachite? Malachite is copper oxide. Okay, so this thing has copper and it has oxygen. So copper oxide. Okay, can you all can understand You understand where is everyone today? Is it because of the voting thing? Everyone needs to go back to kampong to vote, so everyone is going back already. Okay, I will. I will. So this is your mineral name. Right, so next, calcium carbonate. What is this? If you still remember, this is your limestone. Okay, batu kapur. The thing you find in many of the caves near in Malaysia. Okay, so where can you find calcium carbonate? You can find it in eggshell. Okay, in eggshell, and of course in chalk. Eggshell and chalk, they both contains calcium carbonate. Your teeth is calcium carbonate. Your nails, okay, is also calcium carbonate. Your bones, also calcium carbonate. A rhino's horn, an elephant's tusk, also calcium carbonate. So calcium carbonate can be found on many living things. All right, so our teeth is one of it. So when you heat calcium carbonate, what's going to happen? Right, when you heat calcium carbonate, they are going to release a type of gas. Can you guess what gas it is? It says carbonate. So what gas is coming out? And we use lime water to test this. Yeah, this one really easy lah. So you can either heat it or you can add acid to it. They will give you the same reaction. They will release carbon dioxide. You remember this, right? You remember this, right? I hope you did it. You did this in school. Did you do this experiment in school? When you heat calcium carbonate, they will give out carbon dioxide. So how do we test this carbon dioxide? We use lime water. We use lime water. So this lime water, this air kapur, when they have carbon dioxide, they turn cloudy or keruh in BM. Okay, so what does it mean? What does it mean? Your lime water is originally clear. That means they look like water. It has no color, none whatsoever. And when you heat this thing, when carbon dioxide comes into this water, this thing will suddenly turn dirty. They will just look dirty. So we call it cloudy lah. Cloudy or keruh. Cloudy. So that's your. So this lime water is like a confirmation test. How do we confirm this is carbonate? Because there's carbon dioxide coming out, this thing turns milky, chalky, cloudy. Now this thing turns cloudy, that means this thing is a carbonate. Okay, I hope you guys understand. I hope you guys understand. So next, the hydrogen gas is released when calcium carbonate is heated strongly. So do they release hydrogen gas? No, they don't. So this is false. It's actually carbon dioxide gas. All right, and of course, number two, the gas release turns the lime water cloudy. I just said it, so yes, this is true. Okay, any of you don't understand? Any of you don't understand? If you don't, please let me know. Okay, please let me know. Right, so this is your calcium carbonate. Right, let's look at the next one, number three. Okay, here it comes. Reactivity. Do you still remember the reactivity series? The list of guys. Do you remember? Kalau nak kahwin mesti ada zakah fantastik supaya perkahwinan cun dan aman. Yes. Yashini, why do you specifically remember that? I have questions. Right. So this is your good looking chart. This is your good looking chart. Okay, let me repeat this again. This is kalau nak kahwin. Okay, kalau nak kahwin mesti ada. Hi Rebecca. I thought you are not coming. Mesti ada zakah fantastik supaya perkahwinan cun dan aman. Okay, so I hope you guys remember this. So if you attended my class few months ago, this should look familiar to you. Okay, okay, right. So if you attended my class few weeks ago lah. A few months ago, you will remember this. Okay, so what is this? Right. So let me quickly talk about this. K is potassium. So this one you have to know lah. K is potassium, Na is sodium. Because if you do it in BM, this is simple because K is gallium, Na is natrium. So potassium, sodium, Ca is calcium, Mg is magnesium, Al aluminium, Zn zinc, Fe is iron. Okay, iron, Sn is tin. You know PGT ma? This is the tin lah. And Pb is lead, Cu is copper, Ag is silver. You might say, sir, can I just memorize the English name? Yes, you can, but you have to make your own story. Okay, you have to make your own story. Okay, I think I did tell you my method also, but I kind of forgot about that one because this is what I memorized. Right? And next year, if you are going to chemistry, if next year you're going chemistry, you are still memorizing this, you're not running away. You have to memorize the symbol. Right? So might as well you do it this year. So this is what you memorize. So let me explain it. So kalau nak kahwin mesti ada, you know what's zakah, right? Zakah is your PP. You must have fantastic PP to have a good wedding, to have a good marriage. Okay, supaya perkahwinan jun dan aman. Okay, so that your marriage is good and peaceful. So you need zakah, fantastic. You need a big PP. If not, your wife will say, why is your PP so small? I'm not happy. So you guys won't have happy marriage. Okay, makes a lot of sense, isn't it? Okay, true story. Right. Anyway, so the taller the guy is, okay, these are a list of guys. Okay, a list of lelaki, okay, a list of guys. So the taller a guy is, the more attractive he is, right? So I've mentioned this previously already. So reactivity or reactive means good looking. The more reactive you are, the more good looking you are, right? Because girls, they react to you because they're very good looking one. So the taller the guy is, the more reactive they are, the more good looking they are. So K here is the best good looking, the best looking is like 190 cm, okay? Because this is like height. Think of this like height. The taller a guy is, the more handsome he is. I mean, not really that way, but generally true. I mean, you wouldn't want to marry like AG here because silver is like what? 160 cm? Okay, I mean, not really 160 lah. I'm just giving you an example. Right? So, for example, like girls, you don't believe me, you go and ask girls. Would you accept, okay, for example, okay, let me just ask you like girls, would you want your boyfriend next time to be 160 cm? Would you accept a guy who's 160 cm tall? Now, right, easy, I got my answer, no. Definitely not, isn't it? I mean, moment of silence for guys who's 160 lah. Oh, because you're 160, right? Right, okay. Fair enough. All right, so that's why, okay, so who's the girl here? The girl is Oxygen, right? Remember? Oxygen is the hot gal that everybody wants, right? So Oxygen would very much, you know, get married to K, to Potassium, because he's really good looking. He's like really mind-blowing good looking. Whereas Oxygen, she doesn't really want to do anything with Silver because he is goddamn awful ugly. All right. So that's why when you get things from the ground, when you get, you know, metals from the ground, very seldomly you will hear silver oxide because Oxygen doesn't want to marry Silver because he is, you know, he's ugly, right? He's ugly. So as a girl, you would not marry him. So you want to marry as high, as tall as possible. So if you marry someone from the front, like potassium, sodium, calcium, magnesium, aluminium, you will be very happy because they are really good looking, really tall. So the reaction will give you very bright flame. Okay, you should remember this. Okay, very bright flame. And if you go down some more like aluminium, zinc, iron, when Oxygen marries these three or these five, the reaction is not so happening, not so vigorous, you know, not so crazy already because the girl is, you know, I mean, if you marry lead, Pb, are you happy? Not really, isn't it? Because it's like, not so good looking also. So the thing doesn't even burn, it just glows. Right? And please remember this, CH is here. Okay, I just remember it as Tsinghua. I mean, you guys attend Tsinghua's class, right? So in between Tsinghua's, okay, in between Tsinghua, there's a Zaka. I mean, he's a guy, so he has a PP, isn't it? So that's how I remember. So between Tsinghua, there's his PP. It's very easy to remember one. So this is how, okay, we remember. Right, so number 3, arrange the following mineral according to reactivity in descending order. Right, so descending order from the best looking guy, the most lang zai one, the most good looking one, to the least good looking. So who is the best looking here? Of course, it's magnesium. Wow, you see, magnesium is like right up there. So magnesium is very good looking, very tall guy, right? And then followed by aluminum. Okay, aluminum, followed by iron. Okay, so this is 1, this is 2, iron is 3. And the last, which is the worst looking one, that would be your gold. Right? You might say, sir, where is gold? Gold is not even, it's not even on this list. Gold is like right smack at the bottom, the most bottom. That's why you don't hear gold oxide. You will never hear gold oxide because oxygen doesn't react with gold, because gold is very stable. Okay, gold is very stable, and gold, they don't, gold is really ugly. Okay, so as a girl, as a very good looking girl, oxygen, you wouldn't want to marry gold because he's even shorter than 160. Okay, would you want to date some guy who's 1.5 something? Well, you tell me. Okay, he's even shorter than you. Chances are. Right, so B, complete the following reaction. So iron plus oxygen, you will get iron oxide, barium oxide, and then lead oxide, lead and oxygen, you will get lead oxide, boom oxide. Okay, so iron oxide, lead oxide. So number 4, okay, number 4. So who's above carbon? So we go back here lah. Above carbon, there are these 5. So there are 2 choices here. It's either copper or magnesium. Well, of course, it's magnesium because magnesium is very good looking, very tall. Copper is like last second. Copper is right here. Okay, copper is right here. Guys, you do remember you do understand what I'm trying to say here, okay? And let's talk about extraction. Let's talk about extraction, right? Why do we extract metals? Why do we extract metals? Because most metals, they exist in the form of oxide. Okay, when you get metal from the ground, I mean, besides gold or silver, you will get them in the form of oxide. That means they are not pure, they are married. For example, if you get potassium from the ground, you get potassium oxide, sodium oxide, calcium oxide, magnesium oxide, aluminum oxide, zinc oxide, iron oxide, tin oxide, lead oxide. So everything you get from the ground is like just like, see, everything oxide, one. You get anything from the ground, they are in the form of oxide, which is not, not good. We cannot use this straight, right? Because you see, if you use iron oxide, right? Have you seen iron oxide before? Have you seen iron oxide before? Iron oxide is basically your rust. You see, you can't use this. When you get iron oxide from the ground, they just look like a bunch of stones. Can you use this to build a house? No, you can't. Can you use this to build a car? No, because we don't want iron oxide. We want pure iron. Okay, we want pure iron. Okay, pardon the Minecraft thing lah. This is called iron ingot. Okay, ingot is this thing. You see, this is pure iron. We want this. Right? So how do we go from iron oxide to iron? We have to extract. Okay, I want to go from iron oxide to iron. I need to extract, or any metal, lead oxide, tin oxide, whatever oxide. If I want to use the pure form of something, I need to extract this thing. Right? So how do I extract? How do I extract? There are two ways I can extract. So we look at C. C is our main guy here. You see, C carbon is better looking than all these guys, right? Because C is taller than these, right? So anything lower than C, anything worse looking than C, I can use carbon, I can use C to rampas their wife away, right? Okay, you get what I mean here? You get what I mean here? I can rampas someone not as good looking as me, I can rampas their wife, right? Yes, Zui, hello. We are in this mineral chapter. Okay, so anyway, so right, let me continue this. So iron oxide, when you extract, you get iron. So how do we do this? You see, iron, okay, if there's iron oxide and carbon, you see, now as a girl, you are married to iron. Okay, you are married to iron. Now a better looking guy, which is carbon, come for you. Okay, so what will you do? You are going to dump your ugly ass boyfriend and you're going to follow the better looking guy away. I mean, of course, you won't do that, but just these are metals, okay? They don't practice whatever moral we do. Okay, so they just try to find the better looking guy. So you see, so this oxygen which is stuck to this iron, they will follow the carbon away because carbon is better looking. So now iron is left alone. Okay, can you see the carbon turn into carbon dioxide? And then the iron oxide turn into iron. So the iron is now alone. So now we can use the iron. So this method, we call it extraction, or we call it reduction. Use this to reduce. Right? Yes, Kaipo, hello. Good evening. Okay, so anything taller than carbon, anything taller than carbon, we cannot use this method because you see, if I have potassium oxide, sodium oxide, calcium oxide, magnesium oxide, aluminum oxide, can I use the carbon to rampas the wife away? No, I can't because I'm not as good looking as these five. Right? You guys get what I mean, right? So, which brings me back to here. So, extraction through electrolysis of metal compound in molten state. So, among these two, they want you to choose who is suitable for who. If I use electrolysis, this is for magnesium, which is the taller than carbon one. So anything taller than carbon, I cannot use carbon to rampas their wife. Okay, because carbon is not as good looking as them. Okay, so these five I need to use electrolysis. I need to use electrolysis because, okay, what is electrolysis? Do you remember? I use electric to tear them apart. That means if I have magnesium oxide, if oxygen is married to magnesium, I cannot just use carbon. Hey, can you take magnesium's wife away? Carbon will say I can't because I'm not as good looking as magnesium. So I need to use electricity to break them. Okay, I need to use electricity to tear them apart. You get what I'm trying to say, guys? You get what I'm trying to say, so that's why we for electrolysis we use P, magnesium. Metal extraction is carried out through direct heating. I just heat it until the oxygen goes away. This is your Q. Okay, or I just use carbon to rampas the wife. This is your Q. Okay, because Q here, copper here is lower than carbon. You see, it's lower than carbon. It's not as good looking as carbon. So the thing just, you know, I can just rampas the wife. Right? You guys understand, Okay, so for those who just came in, I did tell you how to memorize this few months ago. Okay, kalau nak kahwin mesti ada zakah fantastic supaya perkahwinan Jun dan aman. You have to memorize this. Guys, even if you don't memorize this, now, okay, next month, sorry, not next month, next year, if you go to your chemistry, okay, next year, if you're going to pure science, if you're going chemistry, you are still memorizing this thing. So there is no running away. You cannot run away from this. So you still have to memorize this. So might as well you memorize it now, right? So next, number 5. So diagram 2 shows the position of metal Y in the reactivity series. So this is your metal Y. So you have your hydrogen here, zinc here. Remember I said, okay, in between Tsinghua, there's the Zaka. Okay, so anything lower, Y is anything lower than H, which is iron, tin, lead, copper, and silver. So what could be the possible? Circle the examples of metal Y. So who is lower than hydrogen? Magnesium is definitely out. Okay, because magnesium is very good looking. Sodium also definitely out, because sodium is like second place. Copper, yes, because copper is lower than hydrogen. Potassium, no. Nothing is better looking than potassium. It's the best looking. And of course, silver, yes. Silver is like last place. Aluminium, no, because aluminium is here. Up here. Okay, guys. Hope you're okay. If you don't memorize this, you are dead. If you don't memorize this, very big chance that you can't do this chapter. So please memorize this. You have to. I already make your life easy by giving you a story here. Okay, so next, underline the correct answer for the following statement. Hydrogen is what reactive than tin? Okay, like I said, reactive is good looking. Is hydrogen good, better looking, or worse looking than tin? Let's see. Okay, hydrogen is here. Tin is Sn. Tin is Sn. So hydrogen is better looking, right? Better looking, right? So it's more reactive. Because reactive is good looking. Like I said, if reactive is like girls react to you because you're very good looking. So if you are very reactive, that means girls, they will shout at you. They are crazy about you. Okay, so next, hydrogen, what, zinc oxide. Okay, so you see, zinc is now married. Zinc has a wife. So can hydrogen run past this wife away? Let's see. So zinc is up here. Okay, zinc oxide. As an uglier guy, as a shorter guy, can you take zinc's wife away? Can you take zinc's oxygen away? No, you can't, because it's not as good looking. It's not as reactive, so it does not reduce. Right? Are you guys following? Are you guys following? I hope you guys are following. This is quite a, I would say, technical chapter, because you have to memorize this thing. But I don't know lah. In my opinion, I think this is easier than chapter 3 lah. At least it's not as hard to memorize as your hard chapter. Okay, the hard chapter is like you need some effort to it. This one I think is still okay. All right, so number 6. So this is a blast furnace. Remember what is this? Like I said, I think your Minecraft has this. Okay, so blast furnace. So can you see 3 piles of things here? Okay, so of course one of it is iron ore. Okay, because this is what you need. Iron ore is iron oxide. You are going to get your iron from here. And then next, this is the carbon. This is the carbon, because we can use carbon to rampas iron's wife, right? I did say this, right? Here, there. You see, I can use carbon to rampas iron's wife. Now I have pure iron. So what is this carbon called? This carbon is called coke. Okay, coke and BM. Coke as in not Coca-Cola, Coke as in the carbon. So what else do we put? We will add one more thing called limestone, because this limestone will form something called slag. What is a slag? Slag is this thing you use to make cement. This one you don't want to know, never mind, it's okay. So this is your blast furnace. So number one, metals that are more reactive than carbon, that means better looking than carbon, in the reactivity series of metals, are extracted from the ores using carbon. That means the better looking than carbons one, again the carbon ones, I can use carbon to run past their wife. Can I? That means anything better than carbon, which is this potassium, sodium, calcium, magnesium, aluminium, I can use carbon to run past their wife. Can I? No, because I'm not as good looking. You see, if your husband is like top 5 best looking, would you follow an ugly guy away? Of course you won't. So you will see no reaction here. So this statement is false. Okay, so this statement is false. Next, number 2. So lead can be extracted from its ore by using the same method as extraction of iron ore. That means how you extract iron ore, like up here, I can use it to extract lead ore. You see, iron oxide, I can use carbon to run past the wife, right? Can I do the same for lead oxide? So we look at the chart again. So if I can take away iron's wife, can I take away lead's wife? Of course you can, right? Because they are also both worse looking than carbon, not as good looking as carbon. So this is true. Okay, so this is true. Right, hope you understand, Hope you understand, so like I said, you have to memorize this. If not, you are dead. Next year you're still memorizing this. There's no running away. And next year it will be worse because next year you're memorizing the charge. I think I told you this before. Okay, what's their charge? Why is it plus? Why is it 2 plus? Why is it 3 plus? You have to memorize them. If not, your chemical equation will be wrong. This is for next year. Okay, so moving on. Okay, moving on. Let's go to the next question. So circle 2 minerals that are crushed during early process of iron ore. So what else do we add to the iron ore? Like I said just now, we add coke and we add limestone. So your coke and your limestone. What is your talc? Talc is your body powder. You know the powder you put at your, Johnson baby powder? Johnson baby powder? Most powder, they are made from talc because they absorb moisture. They absorb sweat so that you don't get smelly. Okay, so next, number 7. Oh, this is uncle's favorite ring, right? I mean, you will see those old uncle wear one of these lah. I don't get what's the appeal. It's ugly as shit. Okay, anyway, so this is a silver stone with jade stone. Okay, let's just say this is gold ring because it looks gold to me. Right, so we have a gold ring and a jade stone. Jade is like Chinese favorite because Chinese they believe that jade is like they bring good fortune to the house or the wearer, whatever Okay, so anyway, so you have your ring and your stone. So what are the types of mineral P and Q? Okay, what are the types? Okay, does anyone know? Does anyone know? Okay the type of mineral, I'll just tell you what you should write Okay, there are 2 types of mineral. Okay, when you get it from the ground, some when you get it from the ground, they are pure. These are known as elements. Okay, also they are your pure metal. And then there's the compound. Okay, sebatian. So compound is like they reacted with something, like all these bauxite, hematite, galena, malachite. They are all compound because they combine with oxygen or sulfur or whatever. Okay, they combine with other stuff, so that's why they are compound. Right, so as you know, there are only three things that exist in element, which is your diamond, your silver, and your gold. Gold, silver, diamond, they are so stable. Okay, they are so ugly in the chart. Oxygen won't even react with them. So that's why they are very stable. They won't oxidize. So Q is definitely your element. Okay, Q is your element. And then P is your compound. Right, let me talk about this. Let me talk about this. Most gemstones, you get it from the ground. Maybe not the ground, but gemstones. Okay, most gemstones, they are compound. Okay, most gemstones, they are compound. Unless you're talking about diamond lah. That's the only thing. The rest of it, they are all compound. Okay, they are all compound. Like for example, you know what is opal? You know opal? This is a really good looking stone, you see? Okay, so can you see they have this kind of translucent look to them? So opal, right? Okay, what is opal made of? Made of, this is not an element, This is not an element, This is silica with water, you see? There's Si, silicon, there's O, oxygen, and then there's H, hydrogen. This is how you put opals together. So you see, they are a compound. All gemstones, they are compound. Like even emerald. Okay, you know emerald? You know emerald? This is a really expensive green gemstone. Okay, so your mineral, your emerald, right? What is inside, you see? You see, you have Be beryllium, you have Al aluminium, you have Si silicon, and you have O oxygen. So you have all these. Okay, so as you can see, they are a compound. In fact, they are a very big compound because it's like a mixture of two ions, two metals here for them to have this kind of green color. Okay, you get what I mean, lah. So your Q, this gold ring is element, of course, because it's pure. And then this P, the stone, is the compound. Okay, there's a Batian because they have different elements inside. So A2, silver or gold, this is gold here. Gold is suitable to make jade ring. Suggest, give two reasons to support this statement. Why use gold? Okay, why use gold? Because they do not oxidize easily. Okay, they don't simply fade. Gold is forever shiny. Okay, I mean not forever lah, but for the longest time. Okay, tidak beroksida dengan mudah. Okay, they don't simply oxidize. And of course, the most important reason as a girl, why would you want gold? Because of its bling bling. Okay, girls like bling bling. Mostly lah, mostly lah. Maybe now you don't, but next time you will. Okay, this is why, when you propose to someone, you need a ring because girls like bling bling. Okay, so let's move on. Okay, let's move on. So this malachite, I'm going to skip. Okay, we're going to skip. This is malachite, by the way. Malachite is a really pretty stone. Can you see? Malachite is a really pretty stone. Okay, they are not like emerald. You see, emerald, they are see-through, but malachite, they are not, and they have this nice, how do I put this, layers. Okay, they have this pattern of layers of pattern on them. Okay, it looks like bacteria. Today, okay, maybe it does. Right, so the circle thing, you mean amoeba? You mean amoeba? or paramecium. Okay, so by the way, this thing is a really cool gemstone, but it's not very common because it's not very scratch resistant. Okay, it's not very scratch resistant. Right, you see, why do we Chinese, we wear certain, I mean, okay, I'm not just Chinese lah, but generally lah, Chinese, we wouldn't wear jewelry like this because they are not very long lasting. You see, malachite is very sensitive to scratches. You wouldn't want to buy a very cool looking necklace, very cool looking gemstone, just for them to get scratched, right? So malachite is like this. Malachite, they are kind of scratchable. So this is why I mean it looks cool and it looks good, but when you scratch them, they will look very unsightly. They will look really ugly. So if you're really scared of that, that's why people buy diamond. You see, diamond will never scratch. But not to mention diamond is very expensive lah. Okay, you get the point. Right, next. Let's go to number 8. Number 8. So this is the same question. Mineral exists naturally in Earth's crust in the form of element or compound, right? Like I said, when you get something from the ground, if it's pure, then it's element. So there's only 3 here. There is your gold, then your silver, then your diamond. Okay, emas, perak, dan berlian. These things, they are so bloody stable. Okay, they are so bloody stable, they won't change even after a few thousand years. Diamond especially, okay, diamond is really stable. Okay, and of course gold lah. This is why gold, they are kind of expensive. Okay, gold is kind of expensive. That's why because they're very stable. Right? That means if you have a gold chain, even wearing it for 20 years, they will still look good after 20 years. Provided you don't get robbed lah. Okay, in Malaysia, here's the thing, guys. Like I think I told you this before. In Malaysia, try not to wear something so valuable because Malaysia is not a very safe place to be. Okay, that's all I'm saying. Right, so compound. Okay, what's a compound? So like I said just now, okay, bauxite. Okay, bauxite. If you don't want to say bauxite, you can say aluminum oxide lah, same thing. Okay, bauxite or aluminum oxide. Up to you what you want to write. Okay, up to you. So number 2, differentiate between natural element and natural compound. This one very easy, right? Okay, natural element, they only consist of one type of atom, Sergenis atom. Your compound, they consist of more than one type. Okay, lebih daripada sejenis atom. So like gold, they are gold, pure gold, no oxygen, none whatsoever. Okay, I'm talking about pure 999 gold, pure 99.9% gold. They are 0.1% of oxygen maybe. Okay, very stable. Okay, so next, B, the diagram below shows a house that is built from various type of substance. So there's your brick, there's your wood. So one of the metal used is zinc. State which part of the house that uses this metal. Okay, so there's only one part of the house here that uses metal, which is the roof. So the roof, I mean, we don't use this anymore lah. Okay, maybe we do, right? My house still does. All right, so your zinc, your roof is made from zinc. You know what is this lah, right? Just by looking at this sheet, you can imagine the sound already, right? Right? When if your porch is made from this material, if it rains, be prepared to to feel annoyed, okay? Because this is really noisy. It's like knocking on tin can. So zinc, I mean zinc is good because it's very lightweight. This roofing is very lightweight, very easy to install. But the sound wise, acoustically wise, it's not very appealing because it's really noisy. Okay. So anyway, so this is your roof. So number two, what is the characteristic of the metal that enable it to be used as B1? So why use zinc? Why don't use iron? Because they are resistant to rusting. They tahan karat. I mean, they still rust lah, but much slower compared to iron. That's why we use zinc. Zinc is, quite tahan for long. So number three, predict the condition of the metal after 7 years. Explain your prediction. So after 7 years, what happens? I mean, they still rust lah. After 7 years, they still rust. I mean, because it reacts with the oxygen in the air. Okay, this thing will rust. Okay, berkarat because it reacts with oxygen in air. Bertindak palas dengan oksigen di dalam udara. Okay, so they still react with oxygen, they still rust. I mean, yeah lah, they can stand rusting for very long lah, but it doesn't mean they're invincible. They still rust, they will still break, but it takes a long time. Okay, so this question is not really that important. So let's go to number 9. Okay, this one, right? I don't think I'll go into this because it's the same as just now. When you heat calcium carbonate or when you add acid to calcium carbonate, you will get carbon dioxide. So your lime water will turn chalky, cloudy, milky, whatever you want to use, or keruh in BM. Okay, so as long as you understand. Right, so next, number 10. Now I can ask you again, because when I taught this, your school haven't taught this yet. Have you guys done this experiment before? Okay, did your school teacher let you do this? The burning magnesium experiment, the one where you see that bright flame thing. Any of you did this? I hope you did. Any of you did this? And then you put this purple colored crystal here. So what is Y? What is Y? Anyone knows? Anyone knows what is your Y? This is a very long name, chemical, we call it potassium manganate 7. Okay, in BM we call it kalium manganat 7. Okay, you have to write that 7, and it has to be that Roman numerals, which is really annoying. You cannot just say 7. Okay, your answer is wrong. So this is your potassium manganate 7. What is the function of this thing? The function is to provide oxygen untuk membekalkan oxygen. To give oxygen to who? Give oxygen to this magnesium powder so that they can burn. You want to see how is the girl reacting when she gets married to magnesium. Of course, you will see a very bright flame because the girl is very happy. You are marrying someone so good looking. You are marrying someone so tall, so good looking. Of course, the girl will be very happy. So in this experiment, you see a bright flame, really bright flame. If you did this experiment, you know what I mean. This thing is so bright, it's like a camera flash. Right? And the reaction goes down lah. The reaction will just slowly go down. That means, right, when you burn magnesium, the flame is really bright. For aluminium, they just burn normally bright. Okay, not as bright as magnesium. Zinc, they just burn slowly. Okay, not as bright. Fe doesn't even burn. Starting from iron, they just kind of glow. So for iron, they only glow brightly. There's no burning. And then for tin, they only glow dimly. Copper is like nothing. It doesn't even react. Okay, so number C, what can be observed at the end of this activity? So what can you see at the end? So you can say magnesium burns vigorously or very brightly. Okay, magnesium membakar dengan cergas or sangat terang. Cergas or sangat terang. That means very bright or very vigorously. The reaction is very happening. Very happy. Because the girl is very happy. She's marrying a very good looking guy. So this is magnesium oxide. Write this yourself. So predict the observation if magnesium is replaced with zinc. Like I said just now, when you put zinc there, it still burns, but they burn slowly. It burns slowly. Membakar dengan perlahan. And it burns slowly. Still burns. Still burns. It's just the girl is not so happy now because he marries Zinc, which is not a very good looking guy. I mean, not bad lah, but not too nothing to shout about. All right. So state the relationship between the vigor of the reaction, that means how vigorous it is, and the reactivity of the metal. So, like I said, the more reactive the metal is, the more vigorous the reaction. Okay. If the metal is very good looking, the bigger the flame. Right? So two safety precaution. This one you can answer yourself lah. Wear goggles, wear lab coat. Do not look at the magnesium with naked eyes. Wear your sunglasses, okay, whatever, things like that. Right. So next, number 11. This is the same question as well. You know what? I want you to look at this D, you understand? So K, they burn bright. L, they glows dim. M, they burn moderately. So why is there a different reaction? Obviously, you can see this is the best looking guy. This is the second best. And this is the worst looking guy because it only glows. So one inference, okay, one inference from the observation. So you need to explain why. Okay, you explain why because K is the most reactive and sorry, L is the least reactive. I think so K is the best looking here. L is the loser here because L only burns like not even burning, just glows. Right, so arrange the reactivity of the metals. Okay, that would be your, like I said just now, K, M, L, K, M, L. Okay, the rest you can answer it yourself. Right, so this one I'll just roughly talk about this lah. So you see carbon and zinc oxide. Can carbon rampas zinc's wife? Yes, they can, because kalau nak kahwin mesti ada Zaka, fantastic, and Tsinghua is here. So carbon is better looking than zinc, so the oxygen can be taken away. So can carbon rampas copper's wife? Yes, because copper is not as good looking. Zinc, yes. Aluminium, no. Because you see, aluminium is better looking than carbon, so you won't see anything here. Because the wife of aluminium will not follow carbon away, because carbon is not as good looking. When your husband is so good looking, would you follow this guy? No, you won't. Right? Makes sense, right? Okay, so you can do this yourself lah. I think you can go home and do this. You can check the answer yourself because the rest is just repeating question again and again. Okay, so I hope you understand this revision. Okay, I hope this helps. Very easy chapter. I mean, technical, but once you got that memorization down, it should be very simple. Okay, so I hope you understand this. So I think I'm gonna stop here lah. So thanks for coming. Have a happy Thursday. I will see you again next week. All right. So take care, guys. Good night to you. See you and good night. Bye bye.